branch between R and Y, and L2 is an impedance of branch between Y and B. L3 is an impedance of branch between B and R. So these L1, L2 and L3 are the different branches having impedances. So that is RL, that is it is an RL load. Now how to connect 3 wattmeters in a delta connected network means generally in delta connection network there is no neutral point, so that for each phase we are going to connect a wattmeter, that is the current coil in series with the load, and the pressure coil is in parallel with the same load. So that's why when you're coming to the W1, that's the first wattmeter reading, this is a current coil which is connected in series with L1, and the pressure coil is always connected across the total load. Similarly, while coming to the next wattmeter, here also the current coil is connected in series with the L2. The pressure coil or the voltage coil is always connected across the load. Similarly, while coming to third wattmeter, here also I'm going to connect the current coil in series with the L3, that's the load L3, but the pressure coil is always connected across the load. So that if you want to connect wattmeter to the load, obviously please connect that current coil in series with the load, and the pressure coil is always connected across the load, so that the current coil is used to measure current through the load, and the pressure coil is used to measure the voltage across the load. So if you know the value of current, if you know the value of voltage, then it is very easy to calculate the power. Power P is equal to V into I. If it is AC, then we can take VI cos pi. So what is the cos pi is nothing but the power factor. That is cos of angle between both load current and voltage. So this is a general formula. Now I'm going to take, if I take W1 is connected between the polarities of the terminals R and Y, and the next wattmeter is connected between the terminals are Y and B. The third wattmeter is always connected between B and R, so that I am going to follow the sequence RY, YB, BR. So what is the current through the first wattmeter is, I am going to take this is our first wattmeter. So for the first wattmeter, what are the currents? That means what is the voltage and what are the currents which are flowing. So that when I go to this one, the current through this wattmeter is, let the current is, the branch is connected between R and Y, so that I can take this is IRY, that is IRY. The next wattmeter is connected between Y and B, so the current direction is in this direction because the current coil is connected over here. So I can take this is the next phase current is IYB, so that we can call these are the phase currents. And the next branch is connected between B and R, so that the current through this branch is IBR. The current through this branch is IBR. So IRY is there, IYB is there, IBR also we know that. Then what is the voltage across this branch? Because the current through this branch is IRY, but the potential difference we have to take, because this is a current pressure coil which is connected across the load, so that the function of this pressure coil is used to measure the voltage across the load. Then what is the voltage of this branch? That is nothing but VRY, because the branch is connected between R and Y. Similarly, for next wattmeter W2, the voltage is, that is which is connected between Y and the terminal is B. Therefore, I can take this is VYB. I can take this is VYB. Now the third wattmeter is connected between the terminals B and R. Therefore, here the potential is, I can take VBR. So we already know that current is there, and the potential difference is there for each phases. If it is balanced, if it is unbalanced, how to calculate the total power. So what is the power equation for phase now? So we already know that the power equation is nothing but, so the first wattmeter reading, I can take this is W1. So the first wattmeter reading W1 is equal to, what is the voltage of the wattmeter, VRY. So the voltage of the wattmeter is VRY. Then what is the current through that wattmeter is nothing but IRY. Then what is the angle between those two? That is sine of, that is power factor, cos of angle between these two. So I can take this is pi. Similarly, what is the next wattmeter reading? That is W2. So W2 is this one. So what is the current IYB? What is the voltage VYB? Therefore, I can take this as VYB into IYB, that is the next phase current, into again cos pi. So that we are having same. Because if the load is equal, then each phase angle is to be same, that is pi is same for phase. Then coming to the next wattmeter, W3. So what is the W3 reading? So voltage VBR, current is IBR. Therefore, I can take this is the next voltmeter reading is, wattmeter reading is VBR into IBR into cos pi again. So cos pi. So therefore, we are having W1, W2, W3, 3 wattmeter readings, VRY, IRY into cos pi, VYB, IYB into cos pi, VBR, IBR into cos pi, where cos pi is the phase angle, that's a power factor of the load, per phase load. If the load in a delta connected network, if it is balanced, then the per phase wattmeter reading, that's the power factor is same, that is cos pi, whatever the value appear in the first wattmeter, the second wattmeter and third wattmeter also the same. So therefore, then what is the total reading of the total power absorbed by the load, that I can calculate the total power P is equal to, I can write directly P is equal to sum of 3 readings. Therefore, I can go with W1, that's the first reading, plus the second reading, plus the third reading, that is W3. So therefore, what is W1? VRY, IRY into cos pi. Generally, VRY is a line voltage or phase voltage, because in case of delta connection, the line and phase voltages are same. But IRY is a phase current, not the line current. Therefore, I can take this is V phase, I phase into cos pi. Similarly, the next wattmeter reading also V phase, I phase into cos pi. The next wattmeter reading V phase, I phase into cos pi. Therefore, there are 3 wattmeters with the same reading. Therefore, I can take 3 times of V phase, I phase into cos pi. So, the total power absorbed by the load is 3 times of V phase, I phase into cos pi. If you want to convert this phase into line, there the expression can be changed, that is root 3 times of VL, IL into cos pi. VL, IL into cos pi. This statement is only for balanced load. The load is unbalanced, then this statement will not be appear, because 3 times of V phase, I phase into cos pi will not be appear, because the per phase impedance will be different. Therefore, those calculations will become different, because the power factor of the first phase will be pi 1, power factor of second phase, the second wattmeter reading is pi 2, the next wattmeter reading power factor is cos pi 3. Then 3 different loads are there. Therefore, the power factor of different branches will be different. That's the branches of the load will be different. That time, again, total power we can calculate P is equal to the reading of W1 plus the reading of W2 plus the reading of W3. So individually, we have to add W1 reading, W2 reading, and W3 reading to get the total power absorbed by the load. So if it is balanced, the wattmeter readings of W1 is equal to W2, W2 is equal to W3. If it is unbalanced, then W1 reading is not equal to W2, W2 reading is not equal to W3. 3 readings are different. So this is the way how to calculate power absorbed by the load when the connection is the delta connection. It may be star or delta connection, or it may be balanced or unbalanced connection. So coming to the next one, this is very, very important. That's a 2-watt meter method. So most important thing. So 2-watt meter method. This is most important. All of you, this is very, very important. As per the syllabus also, we are having 2-watt meter method. So please be concentrate on this. This is very, very important. So what says 2-watt meter method means, generally here we are going to connect 2-watt meters. It may be star or it may be delta connection. It may be balanced or unbalanced, so that this is a very flexible method and the easiest method to calculate the power absorbed by the load. When you go to the single watt meter method, that watt meter method is applicable only for star connection, that too balanced only. When you go to 3-watt meter method, that is applicable for both balanced and unbalanced, star and delta also. But in case of, number of watt meters are more in case of 3-watt meter method. But with the same constraint, we can calculate total power absorption with 2-watt meters only. It may be balanced or unbalanced. How we can achieve this result using 2-watt meter method, that I can explain one by one. So generally, 2-watt meter method can be applicable for balanced and unbalanced load, so that you can use either star connected load or delta connected load. So first I can explain about star connected load with respect to derivation part, the phasor diagram and all other. Later I can go to delta connection. Is an impedance which is connected to the first phase R, and Z2 is connected to the next phase Y, and Z3 is connected to the next phase B. So here I am following the phase sequences R, Y, B. We already know that 3 impedances Z1, Z2, Z3 are connected. Now current through the first phase, that is R phase, is nothing but this is IR. The second phase current is nothing but IY. The third phase current is nothing but IB. So here the voltages are there: ER1, EYN, VBN. Generally, it is a star connection. Therefore, we are having some neutral connection. That's a neutral point, N. Now, ERN is nothing but, it is the potential difference between the line R and neutral point. That's why I can take this as VRN. So this is a phase voltage. This is a phase voltage. And what is VYN is nothing but, it is a potential difference between the line Y and the neutral point, VYN. And this is also a phase voltage. So that you can take this is also a phase voltage. Coming to the third phase voltage, VBN. VBN is nothing but, it is a potential difference that the voltage of the given three-phase system with respect to B terminal and with respect to neutral point. So that this is also a phase voltage. So in a star connection, we are going to take a phase voltages. That is ERN, EYN, EBN are the phase voltages. Okay. IR, IY, IB are the current through the R phase, current through the I phase, Y phase, current through the B phase. So earlier I said, in a star connected network, the line current and the phase currents are same. I phase is equal to IL. We already know that, because in a star connected network, the impedance which is connected in series with the line, therefore I can take I phase is equal to IL. That is, the current passing through the phase and the line should be the same. But while coming to the potential difference, it is different. That is already explained and with all derivations. That is, the line voltage is always equal to root 3 times of phase voltages, root 3 times of phase voltage. And if you want to mention the angle, at an angle of 30 degrees. Okay. So this is a general relationship for any star connected network. I phase is equal to IL, VL is equal to root 3 times of V phase. So this is about general structure for a star connected load. Okay. Now, how to connect wattmeters? How many wattmeters we are going to use? 2 wattmeters. So 1 wattmeter I am going to assume W1, and the next wattmeter we are going to assume W2. Why these 2 wattmeters are connected for R and Y phase? Why don't we connect B phase? So it is that is your convenient. You can connect a wattmeter to the R phase or B phase or Y phase, whatever it is. So all different connections, if you connect anything, 2 wattmeters, you can get same result. There is no doubt. For that, I am going to choose 2 wattmeters W1 and W2. Both are connected for the phase R and phase Y. So I'm going to choose 2 wattmeters are connected for R and Y. How to connect these wattmeters for R phase and Y phase? So I told the current coil is always connected in series with the load, but the potential coil or the pressure coil or the voltage coil is always connected across the load. I already told. While coming to 2 wattmeter method, the voltage of the voltage coil of the wattmeter is always connected to the next phase of the system, because here I am going to choose W1 and W2 wattmeters. Those 2 pressure coils or the voltage coils are commonly connected to the next phase only. This is very, very important point you have to remember. Okay. So W1 and W2 must be connected. That is, the voltage coil is always connected to the B phase. The next wattmeter reading W2 voltage coil is also connected to the next phase B. So that in a 2 wattmeter method, the 2 wattmeter pressure coils are always connected to the third phase of the given system. This is common. So whatever the wattmeters, suppose if you connect to W1, suppose if you connect to W1, R phase, here I am going to connect to W1 is for R phase. So and W2 is connected for Y phase. So current coil is always connected in series with the load. The voltage coil is always connected to this B phase. Similarly, for the first wattmeter, the current coil is always connected to the load, and the voltage coil is always connected to the third phase. If you clearly observe this, the first wattmeter, the second wattmeter pressure coils are always connected to a common phase B. Why we are going to connect like this? Why don't we use next connection? Suppose if you have any, if you get a small doubt, so why we are going to connect these parameters or these wattmeters in this manner? I'm going to use next phase. Suppose if you want to connect R1, I mean W1 for R phase, W2 for B phase, again you have to connect the W2 wattmeter reading current coil is in series with the B phase, so that, but the pressure coil is always connected to the common point is Y. Similarly, the first wattmeter reading pressure coil also connected to the Y phase. So while connecting 2 wattmeter method, the current coil is connected always in series with the load, but the wattmeters, both the wattmeters pressure coils are always connected to the next phase. That is, wherever the wattmeter is not available, that phase we are going to connect the pressure coils. This is compulsory. So if you follow this one, then you will get a perfect answer. So why don't we connect Y, RY? Why don't we go for wattmeter first, YB like this? So that is every issue.
Sir, I have a doubt, sir.
Yeah, tell me.
Sir, is it necessary to connect all the wattmeters in a sequence, sir?
No. Not necessary. Here I am going to connect for W1 for R phase, W2 for Y phase. Na? Suppose if you
Okay,
want to
okay, sir.
connect same wattmeter W1 for B, W2 for Y. Okay.
That's what I was
Suppose you
asking, sir.
connect, the wattmeter is connected to the B. So the current coil is always connected to the B, but the pressure coil is always connected to the R. And the next to Y wattmeter ఉంది కదా W2,
Oh, yes,
that
sir.
pressure coil also directly connected to the R phase. అంటే మీనింగ్ ఏంటంటే నువ్వు కనెక్ట్ చేసిన వాట్ మీటర్స్ లో ఏ ఫేజ్ కి అయితే నువ్వు వాట్ మీటర్ కనెక్ట్ చేయట్లేదో ఆ ఫేజ్ కి ఆ 2 వాట్ మీటర్స్ ప్రెషర్ కాయిల్స్ కామన్ గా కనెక్ట్ చేయాలి. అది నువ్వు ఎలా అయినా కనెక్ట్ చేసుకోవచ్చు.
Okay, sir. Okay, understood, sir.
రైట్, థ్యాంక్ యూ. So this is the purpose. This is the way how to connect two wattmeters to find the total power absorption. So here I'm assuming W1 is connected for R phase, W2 is connected for Y phase. Both the current coils are connected in series, here also in series. But the wattmeter 1, the pressure coil is commonly connected to the B phase. The next wattmeter pressure coil also commonly connected to the next phase. This is compulsory how to follow the same significance, not the sequence. That procedure you have to follow. So while coming to the readings, how to take the readings and how to measure the readings, that I can explain. So what he is going to say here is the sum of the wattmeter readings gives the average value of the total power absorbed by the three phases. Generally, earlier I told, if you want to measure the power, it may be balanced or unbalanced. If you want to go for 3 wattmeter method, there you can find the, or you can measure the wattmeter readings, then you can find the total power absorption. That is P is equal to W1 plus W2 plus W3. But while using 2 wattmeter method, here we are going to reduce 1 wattmeter so that we can save the cost. That's the main advantage. So with 2 wattmeters only, I can measure total power absorption, maybe balanced or unbalanced. So that's why while calculating total power absorption, here also we are going to add both the wattmeter readings, W1 and W2. So let us see how to take this one. So here I'm going to show the total instantaneous power. Before going to that, I have to take the values. So what is the first wattmeter reading? That is current through the load is IR. And this wattmeter pressure coil is connected between R phase and B phase. So therefore I can take the voltage is VRB. So don't take VBR, it is quite opposite. So wherever the starting point is there, generally we can call this is the terminals M and L, C, V. M is stands for mains, L is transfer load, C is transfer common point, that is for M and C. That's a voltage coil and current coil. And V is nothing but voltage. So there are 4 terminals for each wattmeter. So this pressure coil is connected between the polarities or the phases R and B. Therefore, the voltage of the first wattmeter is VRB. Current of the first wattmeter is IR. What about the second wattmeter is? Second wattmeter is connected to the Y phase. So the current through the Y phase is IY. And voltage of the second wattmeter which is connected between Y and also same B. So therefore, the voltage of the second wattmeter I am going to take VYB. It is VYB. Now coming to this one, what is next? To calculate the values. So there is a proof to find the total instantaneous power. That is an average power they are going to calculate. So what is the instantaneous power means? Generally, if you're coming to this one, here I already told that these are the phase voltages, ERN, EYN and VBN. Let the current through the first Z1 is IR, current through the Z2 is IY, current through the next impedance is IB. So therefore, I can take total instantaneous power is nothing but the first branch, that's the first phase power, that is IR into VRN. Generally, there is a ERN or VRN, whatever it is, that you have to understand. In the diagram, he mentioned ERN, or else you can take VRN, not VBN. You can take this is V. So the first phase power is IR into VRN plus IY into VYN. The next phase is IB into VBN. Then the instantaneous power measured by wattmeter W1. So what is the W1 reading? So we already know that the W1 reading, I'm going to take power, we are going to calculate. That's why I'm going to take P1. P1 is equal to, what is the first wattmeter reading? So here the first wattmeter is connected with respect to IR and VRB. So that I can take IR is multiplied with, generally there is a VRB. So what is VRB? If you're coming to here, what is VRB here is nothing but, it is a line voltage. VRB is nothing but a line voltage. Therefore, I can write this VRB is like this, VRN minus VYN. That's the difference of two phases. So according to phasor diagram. So VRB is a line voltage, VRN and VYN are the phase voltage. So directly I can take generally this is VBN, not VYN. This is VBN. So VRB is nothing but VRN minus VBN. That is two different voltages. Now, similarly, the instantaneous power measured by the second wattmeter W2, that is nothing but P2, is nothing but current into voltage. So what is the current? That is IY. What is the voltage? VYB. Where VYB is nothing but the line voltage. If you want to represent this line voltage in terms of phases, so that VRB is nothing but a line voltage, and also you can represent this VRB is equal to, I can take VRN minus VBN, VRN minus VBN. These are the phase voltages. Next to line voltage is VYB. So VYB is equal to, I can write, it is a vector difference of two phases, VYN minus again VYN minus VBN. So these are the phases, these are the line voltages. So here I am going to take the second wattmeter reading P2 is equal to the current passing through the IY, not IB, this is IY. So by mistakenly expression will be different. This is IY. So I can write directly because you can get a full clarity. There are a lot of mistakes in the equation. I will go with handwritten. Right. Coming to the first P1. So what is the P1? So P1 I am going to take the power, instantaneous power developed by the first wattmeter, absorbed by the first wattmeter. What is the voltage? VRB into IR. B into IR. What is VRB? VRB is nothing but line voltage, or if you want to mention the line voltage in terms of phases, I can take the vector difference of two phases, VRN minus VBN, right, is multiplied with IR. So this is for first wattmeter reading. What's the second wattmeter reading? Is P2. So what is the P2 voltage and current? So P2 current is IY, P2 voltage is VYB. So therefore, I can take this is VYB into IY. So what is VYB? It is a vector difference of two phases. Therefore, VYN minus VBN. VYN minus VBN is multiplied with that phase current is IY. So this is a reading of P2. So after getting P1 and P2 reading, what is the total power absorption by the load? There we have to take sum of both the readings, P1 plus P2. So when I use P1 plus P2 over here, I can have P1 plus P2, that's the total power reading. P1 plus P2 is equal to, so if I add both the things, that is VRN minus VBN into IR. First one is VRN minus VBN into IR plus, what is the second wattmeter reading? VYN minus VBN into IY. So therefore, I can write over here VYN minus VBN into IY. So if we simplify this one, VRN into IR minus VBN into IR. Similarly, VYN into IY minus VBN into IY. So that we already know that by applying KCL, IR plus IY plus IB is equal to 0, because at neutral point, three currents are 0. That is Here 3 currents are passing to the neutral point. So according to KCL, I can write IR plus IY is equal to 0. Then IR plus IB is equal to, I can replace by minus IY. When I replace this equation over here, I will get the total instantaneous power should be IR into VRN plus IB into VBN plus IY into VYN. So this is the way how to calculate total power absorption using 2 wattmeter method. There is a one more method that is easiest method compared to this method, because you will get total confusion in this method. So what is the second method that I can explain? So since here we did not assume a balanced load or a sinusoidal waveform, it follows that the sum of 2 wattmeter readings gives the total power under all conditions. It may be balanced or unbalanced condition. So by multiplying this one, VRN into IR minus VBN into IR plus VBN into IY minus VBN into again IY. So when I take the common term, that is, what is the common term here? Then based on that, I have to follow this KCL rule, IR plus IY plus IB is equal to 0. Then we have to substitute over here. Finally, you can get instantaneous power is like this. Or else, if it is difficult to find the wattmeter reading using these relationships, then we go for the next method. That is the easiest method. So look at this one. So if it is a delta connected load, how 2 wattmeters will be connected? So look at this one, the connection of delta connection. Here also we are going to assume 3 impedances, Z1, Z2, Z3. So here I am going to take the current directions are like this. Current through the Z1 is I1, current through the Z2 is I2, current through the Z3 is I3. So in this direction, we have to assume the direction of the current. Okay. So let these are I1 and I2, I3 are the phase currents. Let IR, IY, IB are the line currents. We already know that. So here also I'm going to use 2 wattmeters, W1 and W2. So both the current coils are connected for individual phases, R phase and Y phase, but their potential coils or the voltage coils are connected to the third phase B. Or else we can connect to W2 B phase, current coil is B phase, and both the wattmeter pressure coils will be connected to the Y phase. That is your convenient. That is not an issue. So here I'm going to connect 2 wattmeters, W1 and W2 in the same manner while discussing in case of star connection. Here also I'm going to follow the same. So based on this connection, we can follow we can find the total power absorption. So what is the current through the current coil is IR. So the first wattmeter reading we are going to measure, that is W1. So what is W1? So W1 is equal to, what is the current through the first 2 wattmeter? That's IR. So the current wattmeter reading is IR. What is voltage of the first wattmeter? Look at this one. The voltage coil of the first wattmeter is connected between R and B. So therefore, I can take directly VRB. Now, what is an angle? So cos of angle between both these two. Let the first angle is pi. Let us assume. Similarly, what is the next wattmeter reading? Second wattmeter reading, W2. So what is the current through the current coil? IY. So the current through the current coil is IY. What is the voltage across the load? That is here the potential coil of the second wattmeter is connected for Y and B. Therefore, I can take V, Y, B. Again, I can go with cos pi. What is pi? It is an angle between both voltage and current. So then what is the total power absorbed by the load? That is total power absorbed by the load P is equal to the sum of 2 wattmeter W1 plus W2. Like this, we can calculate the total power absorption by the load with the 2 wattmeters. It is very easy. Now look at how to calculate same total power using phasor diagram. From that phasor diagram, how to calculate the power factor, that I can discuss now. So up to this, if you have any doubt about this, please Anybody else?
Sir, I have a doubt, sir.
Yeah, tell me.
So far, we have taken the the last equation of W2 as Iy VBN minus VYN, sir.
Yes, yes. VYN minus VBN, I think. Because this is IY, the potential coil is connected between YB, VYB. So VYN minus VBN. It is quite opposite. Here the
Yes, sir. Yes,
expression
sir.
is totally wrong. Okay. That's why I have written in the separate sheet. This is
Okay,
totally
sir.
wrong. Okay. So I think you better go by phasor diagram. That is very easy to calculate the total power absorption. Not only you have to follow the same relationship, if you understand the concept, then it is very easy to calculate the total power absorption. So whatever I told here, there you cannot follow the same equations. Simply you can calculate voltage and current in the phase angle. If you know the phase angle between both voltage and current, it is easy to calculate the first wattmeter reading and second wattmeter reading. Then the total power absorption you can write directly by add both the wattmeter readings. Suppose, look at this one. What is the first wattmeter reading? So current through the current coil is IR. The pressure coil is connected between R and B. So the first wattmeter reading directly you can write W1. So the first wattmeter reading W1 is equal to, I can write what is the current or voltage, first voltage. So voltage is VRB into what is the current through the current coil, that is load, that is nothing but IR
IR, sir.
into, so cos, what is an angle between these two, VRB and IR, let it is pi 1, let it is pi 1. Similarly, what is the second wattmeter reading? What is the current through the current coil of the wattmeter is IY. The voltage coil is connected for Y and B. So therefore, the second wattmeter reading directly you can write W2 is equal to VYB into what is current IY. So therefore, IY into cos, let it is pi 2, where pi 2 is an angle between both VYB and IY. So if you calculate these calculations for W1 and W2, what is the total power absorption by the load? There you can write P is equal to W1
W1 plus W2,
plus
sir.
W2. So generally in any three-phase system, the total power absorption is always equal to root 3 times of VL IL into cos pi. This is a general expression. So with the two wattmeters, how can you know this relationship? That I can explain. జనరల్గా 2 వాట్మీటర్ మెథడ్స్లో మనం W1 W2 యాడ్ చేస్తే టోటల్ రీడింగ్ వస్తుంది. ఆ రీడింగ్ దేనికి ఈక్వల్గా ఉండాలంటే జనరల్ పవర్ ఈక్వేషన్కే ఈక్వల్గా ఉండాలి. దట్ ఈస్ రూట్ 3 టైమ్స్ ఆఫ్ VL IL into cos pi. How to achieve this relationship? That I can explain with the phasor diagram. There you can understand how it is possible. Okay? Right. Coming to the next concept is power factor measurement 2 wattmeter method. So how to measure the power factor using 2 wattmeters? There I can explain for both delta and star connection, so that with the phasor diagram only you can understand. I think this method is very easy to calculate the total power, right? Look at this diagram. There are 2 wattmeters. There is a 3-phase supply. This is a supply. So, and this is a load. So always the representation of source to load direction is like this. So let the 3 phases are R, Y, B, and 2 wattmeters. Let us choose W1 and W2. Earlier I told the number of turns for the current coil is very less compared to the pressure coil. And also you have to mention the thickness of the current coil is always very high. So when the thickness of the current coil is very high, the diameter of the current coil will be high. So when the diameter of the current coil is very high, its resistance is very, very low. That's why the current which is passing through the current coil is more. While coming to the pressure coil, the diameter is very less, so that obviously the voltage of the pressure coil is more. That concepts and diameters, current calculations, voltage calculations, resistance, and all other you can study by coming subject, that is electrical measurements and instrumentation. There you can study about full details of wattmeters. Now itself, it is not necessary. Okay, so W1 is connected for R phase, W2 is connected for Y phase. Here also I'm going to take the three phase currents IY, RYB. Three phases are RYB. So here three phase balanced load I am going to assume. That to balanced load either star connected load or delta connected load. Now coming to this one. So power factor measurement by 2 wattmeter method. This is very, very important. Power factor measurement by 2 wattmeter method. So earlier I told same wattmeter connection for star connected network. So Z1, Z2, Z3 are the three phase impedances. Let here I'm going to take VRN, VYN, VBN. So in that diagram I am going to replace this is VRN, this is VYN, this is VBN. Let us assume like this, or else I can go with the green color. Right. This is VRN, this is VYN, this is VBN. So since the load is balanced, here I'm assuming load is balanced. Same, the current coil, that is the first wattmeter reading. Current through the current coil is IR, and voltage of the first wattmeter, which is connected between the R and B. So the load is balanced means IR is equal to IY is equal to IB is equal to IL, because in case of balanced load, per phase impedance is same. Therefore, current through the each impedance is to be same. So in case of star connected network, the phase and line currents are same. That's why I'm going to take IR, IY, IB is equal to IL, where IL is the line current. Similarly, coming to the phase voltages, VRN, VYN, VBN are the phase voltages, because the phase voltage is nothing but the potential difference between a phase, that's a line and neutral point. Let this neutral point is N. So the line and neutral point. These are the phase voltages. Since VRB, what is the line voltage? So the first wattmeter reading is VRB, voltage reading of the first wattmeter. What is the second wattmeter current? It is IY, and the voltage of the second wattmeter reading is VYB. So what is VRB? VRB is the line voltage, and it is a vector difference of two phase voltages, VRN minus VBN. Similarly, what is VYB? It is also line voltage, and it is a vector difference of VYN and VBN. So we can determine the line voltages VRB and VYB using phasor method. So using phasor method, we can find this line voltages VRB and VYB. So this power factor, how to measure these values, that now the time is 10:25. So 5 minutes to go. I can complete up to here. Later I can go with problems. Okay. Right. So VRB is nothing but potential difference between VR and VBN. That's the difference of both the phase voltages. VBI is nothing but phase voltages difference, VYN and VBN, so that we can determine these line voltages using phasor method. So what is a phasor method? So earlier I drawn the phasor diagram also there. There we have to understand how to draw the phasor diagram. Look at this one. Let us draw the phases first. So don't go to this entire paragraph. First to leave that paragraph. Don't see that. First to see the phasor diagram. From that only you can understand. From that phasor diagram only, I have written these points here. So what is first three phase voltages VRN, VYN, and VBN, which are displaced at 120 degrees to each other. That is VRN. And the next phase will be VYN. So this is the second phase, VYN. And the next phase will be, I'm going to choose VBN. So this is the next phase, VBN. Then, what are the line voltages required for our analysis? So here the line voltages is VRB, VYB is enough. So then what is the required of phases? So that when I draw the negative phase for VBN, I can draw the dotted line with respect to minus VBN. So this is minus VBN. Similarly, I need one more negative vector because there are, VBN is common in both the cases. Here is VBN, here is VBN. So only one negative vector will be required, that is minus VBN. Then what is VRB? Vector sum of VRN and minus VBN. So as per the parallelogram diagram, so draw the parallel vector from VRN with respect to minus VBN, and also draw the vector from minus VBN with respect to VRN. So both the vectors can meet at this common point. So join both the lines and you can get one vector. This vector is a line voltage of both R and B. Therefore, I can take this as VRB. The line voltage of the given vector is VRB. Similarly, what is here is VYN is there, minus VBN is there. Again, take the vector sum of these two vectors, VYN minus VBN. So that we have to draw a parallel vector from VYN with respect to minus VBN. Again, we have to draw one more parallel vector from minus VBN with respect to VBN. Now both the vectors can meet at common point. Now join a line from the origin, a straight line. Now this line voltage always equal to this is Y and this is B. Therefore, I can take this is VYB. Okay, two line voltages are clear. Now, what is IR, IY, IB? Let us assume the load connected over here, it is an inductive load. For an inductive load, if you take voltage is a reference, the current is always lags by an angle pi for an inductive load. I already told in the previous class. The supply voltage is V, the current is always lags supply voltage by certain angle of pi. Similarly, here I have three loads. Load, Z1, Z2, Z3. Here assuming balanced load. That's why IR, what is IR in the diagram? IR is nothing but the current through the first phase. What is the first phase voltage? VRN. So if you draw VRN is a reference, automatically the current through the load will be lags by certain angle pi. So here the angle between IR and VRN is pi. This angle is pi. That means IR lags VRN by pi. Similarly, same IY lags VYN by certain angle of pi. Similarly, IB lags VBN by an angle pi, because we are assuming it is a balanced load. So after connection of all these, after mention all the degrees, all the values in the diagram, let us see this one. This is an angle between both VR and VRN, VRN and IR, right? That is nothing but pi. Now, we already know that the angle between a line and the phase is always equal to 30 degrees. I'm right? This is 30 degrees because in case of balanced load, the line voltage always leads the supply voltage by the phase voltage by 30 degrees. So then what is the angle between these two, VRN and VRB, is nothing but 30 degrees. So what is an angle of this portion? I already know that angle between IR and VRN is pi. Angle between VRN and VRB is 30 degrees. Now, what is an angle between IR and VRB? This is very, very important because I need to calculate the angle between these two, because what is the first wattmeter reading? W1 is nothing but IR is multiplied with what? VRB. So I required angle between both IR and VRB. Then what is this angle? Can anybody please? The angle between VRN and IR is pi. Angle between VRN and VRB is 30. Then what is the angle between IR and VRB?
30 minus pi.
Right, excellent. 30 minus pi. So therefore, the angle between these two is 30 minus pi. That means IR as well as VRB. Similarly, what is the next wattmeter reading? So the next wattmeter reading is W2. What is the
VYB,
current
sir.
through the W2 is IY. It is VYB.
IY,
Now I would like to
VYB.
take angle between IY, VYB. I'm going to calculate angle between these two. So IY is there, VYB is there. Now what is an angle between these two?
30 plus 5, sir.
30 plus pi. Excellent. So the first wattmeter reading is to be 30 minus pi. The next wattmeter reading is to be 30 plus pi. Therefore, what is the total power absorption? That is the first wattmeter reading is P1 is equal to VBR, VRB into IR into cos 30 minus pi. The second wattmeter reading P2 is equal to VYB into IY into cos 30 plus pi. So we already told that VRB is nothing but line, IR also line. Therefore, VL IL into cos 30 minus pi. Similarly, the second wattmeter reading is VRB is nothing but a VL, IY is nothing but IL. Therefore, VL IL into cos 30 plus pi. So remember up to here. The rest of the part I can explain in the next class. CRs, both the SANC and ASID, please share the attendance, please.
Okay, sir.
Right, up to now, any doubts? If you have any doubt, please post in the group regarding this concept, then I can give some information. And also I can provide videos how to measure power in a 2 wattmeter method. That all, and I can share the PPTs and also videos are the materials. Better always go with the textbook. Textbook minchina knowledge ledu. You better go through the textbook. It may be Chakrabarti or it may be Alexander or any other textbook. You have to refer to find how to calculate total power absorption by using 2 wattmeter method. There are different connections, different calculations, but ultimately final answer is to be same. Okay. Okay. Thank you.
Okay, sir. Thank you.
Right.